Okay. So shall we get started? See, what is the answer for the first one? Guys, can I have some response? Am I audible?
Yes, sir.
What is the answer for the first one?
Will not interact with each other.
Two parallel beams of positrons moving the same direction will
Attract.
no. They will repel each other. I already told you, when the currents are in the same direction across two parallel wires, they repel. Two. Oh, sorry. Same direction.
Same direction, attract.
That they should attract. So I have to change the answer in the answer key. So it's given as repel, which is wrong. They attract.
Sir,
Tell me.
sir, is positron as same as proton? Photon.
There's something similar only. There's something similar. 1 minute. 1 minute. Oh, guys, I'm sorry. 1 minute. I missed something. Yeah, sorry guys. So what is it? You asked me something like positron and proton. See, proton is basically H plus. Positron enaguna, it is written in the form of electron. Imagine an electron having a positive charge. So that is actually a particle which is released during a process called as radioactivity, which is not there in your syllabus. Nuclear, that part is deleted. So other than the positron, சரியா?
Okay, sir.
Yeah. Next. So electron and proton have the same kinetic energy, enters into magnetic field perpendicular. Then the path of the electron is so R is equal to what do you write? With the same kinetic energy, I already gave you a formula for it. R is equal to root of 2m into k divided by q into b. Correct? They enter with the same kinetic energy. Then what is it directly proportional to? It is directly proportional to. So R is equal to root of 2m into k divided by qb. So what is it directly proportional to? Directly proportional to the mass. Am I right? So because the charge of proton and electron are going to be the same. So R is directly proportional to square root of m. So which one has lesser mass will have the lesser curvature. So answer will be this one. The path of the electron is less curved. Okay. So two infinitely long wires carrying currents in opposite direction. The field at any point lying midway between them will be. What is the answer? It will be twice the field due to each wire. Because when the currents are flowing in the opposite direction, the magnetic field on either side of it will be in the magnetic field due to the current carrying conductors on either side of it will be in the same direction. They'll get added. So most of them will choose 0. That is not right. Answer is twice. A proton enters a magnetic field of intensity 2.5 Tesla, making an angle 30 degrees with the magnetic field. If the force experienced by the proton is this much, then the velocity of the proton is how much is the answer? Force is equal to QVB sine theta. So force 5 into 10 power minus 12 is equal to Q is how much? 1.6 into 10 power minus 19 into V is going to be, that is what we need to calculate, into 2.5 into sine 30 is going to be a half. So what will be the answer? 0.8 into something. So 8 into 10 power minus 20 is equal to 5 into 10 power minus 12 into 2.5. So 2.5, I'll write it as 5 by 2. This will go 4 times. So 5 and 5 are lost. So V will be equal to 1 divided by 4 into 10 power 8. So it will be 0.25 into 10 power 8 or 2.5 into 10 power 7. This is the answer. Fourth one is A. Okay. Next. In a certain region of space, the electric field and the magnetic field are perpendicular to each other. An electron enters into a region perpendicular to both undeflected. Then the velocity of the electron is E divided by B. This is called as velocity selector. If the angular momentum of an electron revolving in a circular orbit is L, then the magnetic moment is given as answer.
EL by 2.
EL by 2m. How did you get it?
Sorry, MV.
So angular momentum is MVR. Correct? Magnetic dipole moment. So what is the magnetic dipole moment? It is going to be pi r square into I. So A into I. So in the place of I, what can I write? Pi r square into I charge divided by time taken. So E into V divided by 2 pi r. Am I right? So idu cancel pi and pi are lost. So it is EV divided by 2. EVR divided by 2 multiply and divided with M. So you will get E into MVR divided by 2 times M, which will be E into L divided by 2M. If you remember, this is a part of some derivation. What derivation is this? This is actually one of the steps of the derivation. We calculate the dipole moment due to an electron which is revolving around the nucleus. Remember?
Sir, this is gyromagnetic ratio, right?
Yeah, that's what they say. Yeah.
Okay, sir.
Okay, what is the answer for the next one?
Rate at which the current change.
Two coils are placed close to each other. No, it's not rate. It depends on the orientation. So previous question, what was it? Magnetic dipole moment, mu is equal to E into L. I think mu by L is what is called as gyromagnetic ratio. So E by 2m is what is gyromagnetic ratio.
Okay.
So relative position and orientation of the coils. That is the answer for seventh one. 8. A solenoid of length 1 meter has a self-inductance L. The number of turns are doubled, and then the self-inductance will be. Answer. It becomes 4 times because it's directly proportional to n square. So 4 times. 9. The SI unit of magnetic flux, simple, Weber. The magnetic flux linked with the coil is the magnitude of the induced EMF at T is equal to 0 is d phi by dt is equal to, differentiate it and substitute the value. What will be the answer? d phi by dt, they ask the magnitude. So 60 plus 4. So 16 should be the answer. Rick option, that is the answer, 10th one. Yeah. The average induced EMF in a coil when a current changes from 0 to 2 ampere in 0.05 seconds is 8 volt. Then the self-inductance is. So E is equal to L into delta I divided by delta T if I take only in terms of magnitude. EMF on the L, 8 is equal to L into 2 divided by 0.05 will be 1 by 20. Am I right? So which implies L will be equal to 1 by 5. 1 by 5 is going to be 0.0. Sorry, 1 by 5 should be 0.8. Is there an option? 1 by 5 should be 0.2. Sorry, I was
0.2.
Yeah. I was having 4 in mind. So 0.2. Virka option. So 11th one, C is the answer, correct. Next, if the angular speed of rotation of an armature of the alternating current generator is doubled, then how much is the induced EMF doubled? So what is the answer?
Twice.
So E is equal to another formula. NBA omega. Correct? So N is, if the angular speed of rotation is doubled, so omega is doubled, then how will the induced electromotive force change? It will be doubled. It will become twice. So 12th C. The quantity that remains unchanged in a transformer is. Answer.
Frequency.
The alternating current through an inductor is given as I is equal to I naught into sine of 2 pi n into t. Then the magnetic field energy of the inductor changes from minimum to maximum value in a time equal to. So how much time does it take for the energy to change from 0 to maximum? It takes 1/4 of the total time period. Right. So 2 pi into n is equal to omega. So n is equal to omega divided by 2 pi. Then what will be t? T will be 2 pi by omega. Right. T will be 1 by n. So what will T by 4 be? Because all the options are in terms of n. Answer will be 1 by 4n. How many of you did this? Did you understand what I told? So it is basically like simple harmonic motion only. That the energy will become least to maximum between 0 to T by 4. In a transformer, the number of turns of the primary coil to the secondary coil are 5 by 4. Answer. So E2 by E1 is equal to N2 by N1. So N2 by N1 will be 4 by 5. E2 is equal to 4 by 5 into 220. So what do I write? E2 by E1 is equal to N2 by N1. Is this not equal to I1 by I2? Correct? Because E1 I1 is equal to E2 I2. We assume that there is no power loss in an ideal transformer. So E2 by E1 is N2 by N1. So it's inversely proportional to I1 by I2. So N2 by N1 evrada? 5 by 4, right? So the ratio of the current in the primary to the secondary is going to be 5 by 4. Irka. So on answer is D. Wait, 15 they're given A. Wait.
So it's 4 by 5.
4 by 5.
Oh, that is N2 by N1 is 5 by 4. 4 by 5 is the answer. 15th. Next. E is equal to E naught sin 100 pi into T is applied to a current. The phase difference between the current and the voltage. So, solra.
Sir, sir, here ratios asked between primary to secondary, right?
I1 by I2. I1 by I2 will be N2 by N1. So N1 by N2 on the 5 by 4. Up N2 by N1 is 4 by 2.
Okay, sir.
Okay. Yeah. Next, AC voltage E is equal to E naught sin 100 pi into T. Sorry, 100 T is applied to a circuit. The phase difference of the current and the voltage is found to be pi by 4. Then, what is the answer, guys?
Option B.
How did you do? How did you do?
Sir, I actually just substituted the options, sir. I don't know how to do it.
But that's what. How did you substitute? That's what I'm asking. What logic did you use is what I'm asking.
Your voltage lead,
Voltage is leading the current. Okay. By pi by 4.
when
Okay. So what
Sir,
are
I
you
used
planning?
power factor.
Power factor another. Power factor will be
Cos phi is equal to 1 becomes.
cos phi is equal to 1 by root 2. Ena pi by 4
Nice.
the difference. Okay. Cos phi use panni appuram enna panna? Then you calculated R by Z.
Yes, sir.
Okay. So here Z will be equal to root of 1000 square plus 10 into 10 power minus 6 the whole square. So when you calculate this, you need to substitute it here and check. So whichever gives you 1 by root 2, that will be the answer. So option adala pathana A will give you the answer. So L can be rejected. RL you need not even calculate. Am I right? Because the voltage is leading the current. So it happens only in an RC circuit. Okay, so we can reject RL. So option A and D, if you check it, then the answer will come out to be option A. Okay. There's a good problem. I want you all to try it again. What answer? How is the answer for this? The magnetic fields are repelled by a magnetic substance. Answer will be Takkan solunga. Diamagnetic. The susceptibility of a ferromagnetic material is inversely proportional to the temperature. 19. Which one of the following will describe the smallest circle when projected with the velocity v perpendicular to the magnetic field? Is it an alpha particle or a beta particle? Answer. So R is directly proportional to M divided by Q. So R alpha divided by R beta will be equal to M alpha by Q alpha divided by M beta by Q beta. So what is M alpha? Mass of alpha particle is
4 times proton.
4 times that of proton into by. What is Q alpha?
2 times proton.
2e, the whole divided by mass of beta. Mass of beta is equal to mass of an electron. Beta particle is basically an electron. So me divided by what is going to be the value of q beta, the charge of beta particle. That is going to be charge of an electron. E and E will get cancelled. So this will go twice. So 2 times mp divided by me. So mass of proton by mass of electron, which one is going to be more? So this will be a ratio greater than 1. So R alpha will be greater than R beta. Which one takes the smaller radius? Beta particle. Puriyadada? You need not sit and solve it. If you are able to say that this ratio is greater than 1, then it is more than sufficient. Okay. Next, 2 identical wires P and Q, each of radius R and carrying current I, are kept in a perpendicular plane such that the common centers. Find the magnitude direction of the net field at the common center of the 2 coils. So if I take this to be 1 and 2, what is going to be the magnetic field due to 1? It will be mu naught I divided by 2 perpendicular identical. So 2a. B2 evlo irukum, that will also be mu naught I divided by 2a. So since the coils are perpendicular, their magnetic fields will also be perpendicular. So the net magnetic field will be equal to root of B1 square plus B2 square. So you will get root 2 times mu naught I divided by 2a. That is the answer. So for direction, due to the first coil, the magnetic field is upward. This is B1. And due to the second coil, the magnetic field is rightward. It is B2. So the resultant will make an angle exactly 45 degrees with respect to either B1 or B2. And that will be the answer. Okay.
Sir?
Hmm.
Sir, here direction will be like theta will be equal to tan inverse of B2 cos theta sin theta by B1 plus B2 cos theta.
It's just 45 degrees. So 45 degrees with respect to both. That's it. Tan inverse B1 by B2 or B2 by B1, whatever you're going to do, it is going to give you 45 only because B1 and B2 have the same magnitude. In this case, it doesn't matter.
Okay, sir.
Okay. So 2 circular coils, one of radius R and the other of radius capital R, are placed coaxially with their centers coinciding. Obtain an expression for the mutual inductance of the arrangement. So answer. Placed coaxially, right? So if this is 1, this is 2, this is capital R, this is small r. 2 circular coils, one of radius smaller and the other of radius capital R, are placed coaxially with their centers coinciding. Okay. Obtain the expression for mutual inductance of the arrangement. So what is the magnetic field produced due to the second coil? Is it not mu naught into capital I divided by 2R? Okay, let me say the current here is I2 and the current here is I1. So what is the formula for mutual inductance, guys? So M21 in our
N2 by I1.
N2 divided by
I1.
I1. So here I'll write it as I2. Then what is M12? N1 divided by I2. Okay. Now tell me what will happen. If I need to calculate M12, then what is going to be number of turns if I take it to be, since they told 2 circular coils. Okay, I don't know how many turns it has. I'm assuming it has 1 turn, for instance. Okay. Then what is going to be the value of phi1? Can I say magnetic field produced due to the second coil, because that is the one in which the current is flowing. into A1 the whole divided by I2. So what is the magnetic field produced due to the second coil? It is mu naught I2 divided by 2 capital R, mu naught I2 divided by 2 times capital R into what is the value of A1 pi R square, small r square, the whole divided by I2. I2 and I2 will get cancelled. You will have mu naught pi small r square divided by 2 times capital R. This is going to be the mutual inductance of 1 with respect to 2. Then what about 2 with respect to 1?
It will be same.
Let's calculate and see. M21 will be equal to B1 A1 divided by I1. Why I wrote B1 A1 not I2? Because whatever is a magnetic field generated due to the smaller coil will be the same magnetic field associated with the bigger coil also. I mean the flux. So B1 is going to be how much? Mu naught I1 divided by 2 small r into pi r square divided by I1. I1 and I1 will get cancelled. Small r and small r will get cancelled. It will be mu naught pi into small r divided by 2. Okay. So this is how it works. They are not the same actually. Okay.
Sir, in case of solenoid, it will be same.
In case of solenoid of equal length, they will be same. If not, they are not same.
Okay. Sir.
Okay. And those two solenoids are supposed to be placed coaxial.
Okay.
Okay. A source of EMF E is used to establish a current I through a coil of self-inductance cell. Show that the work done by the source to build up the current I is this value. So we know that E is equal to L into di by dt. Power is equal to E into I, but power is equal to work done per unit time. So E into I is going to be L into I into di by dt. So dt and dt are gone. dw will be equal to L into I into dt. Integrate on both the sides. You will get work done is equal to L into I square divided by 2. Okay, and this work done is what is going to get stored in the form of magnetic field inside a inductor. Is that clear? So this is all theory only. So coil with an air core and an electric bulb are connected in series across a 220 volt 50 hertz AC source. The bulb glows with some brightness. How will the bulb glow of the bulb be affected on introducing a capacitor in series with the circuit? There is an important problem. Mark it. So what will happen, guys? So when you introduce a capacitor, right, what will happen to the impedance? It will become root of R square plus XC square. Am I right? Guys, are you able to understand? A coil with an air core and electric bulb are connected in series across a 200 volt So coil with air core is actually an inductor and an electric bulb is actually a resistor. So this is an inductor, this is a resistor. The bulb glows with some brightness. Okay. Now what will happen when a capacitor is introduced in series? What will happen to the impedance? So initial case, what was the impedance? Z was root of R square plus XL square. Final case, what is going to be the impedance? Z will be equal to root of R square plus XL minus XC the whole square. So what is happening to the impedance? Z dash is less than Z, which implies I will be more. When current is more, the brightness is more. So whenever you have a problem based on this concept of brightness, the steps you're supposed to follow is first find out the impedance. Once you find out the impedance, find out if that is increasing or decreasing. If it is decreasing, then current will increase, brightness will increase. Okay, as I told you, mark it as important, and you have a similar kind of problem in alternating current examples. So try that problem. Okay, you might get it. From your NCRT, you might get it. Try that. So explain why the reactance offered by an inductor increases with increase in the frequency. Very simple. XL is equal to 2 pi into F into L. XL is directly proportional to the reactance offered increasing. XL is directly proportional to the frequency. So that's the answer. Next, using the relation for potential energy of current carrying planar loop in magnetic field, obtain the expression for the work done in moving the planar loop from unstable to a stable position. So what is the answer? So what is the formula for potential energy when a dipole is placed in uniform magnetic field? U is equal to minus mb cos theta. So what are they asking? Expression for work done moving a planar loop from its unstable equilibrium to a stable equilibrium. For unstable equilibrium, what is the value of theta? It is 180 degree. So what is the value of U1? Initially, the energy possessed is mb, because cos 180 is -1, minus of -1 is going to be +1. So when it goes to stable condition, theta will be equal to 0 degrees. So U2 will be equal to minus mb. So what is going to be the work done? Work done is equal to U2 minus U1, which is going to be minus mb minus mb. So answer will be minus 2 mb. Okay. Next. So 5 long wires A, B, C, D, E carrying current I are arranged to form edges of a pentagonal prism as shown in the figure. Each carries a current out of the planar loop. So the direction of current is like this. Okay. What is the magnetic induction at a point on the axis O and the axis at a distance capital R from each wire? So what is the answer, guys? Anybody who could solve this?
So it will be 0.
It will not be 0, because had it been 4 wires, the answer would have been 0. But it is not 4 wires, you have 5 wires. So tell me, due to which wires will the magnetic field get cancelled? Did you understand the question? See, the dot is placed, no, that is the direction of current. So the current is towards you. So E and C will produce the same amount of magnetic field at point O because they are at the same distance. So sorry, not E and C, E and B will produce the same magnetic field and they will get nullified. So this is gone, this is gone. So the vector sum will cancel it out. D and C will also cancel out, but you don't have a counterpart for A. So A will be the only current carrying wire which will produce a magnetic field. So what is the magnetic field due to a straight current carrying conductor at a distance R from it? Mu naught I divided by 2 pi into capital R.
Sir, how will E and B get cancelled? So they're not in a straight line. E or B isn't a straight line.
E and B are, see, they are symmetrically placed. And E and B are, see, the wires are like this, okay? The wires are like this and they carry the current in the same direction. What is the magnetic field at the center?
Sir, but they still have a component along OA, right, sir? That won't get cancelled.
Component, it's a long wire. Y component will come. Long wire. You
Okay, sir.
see, again, I think you're getting confused. AB is not the wire. B is like this actually. You're able to see the dot, but when you see, go to the side and see, you'll actually be able to see like this. This is the wire through B. This is the wire through E. And O is somewhere in between, exactly symmetric to both. So when current in both the wires are in the same direction, will the magnetic field at the center not get nullified? That's what I told.
Sir,
Okay.
can you draw the vectors of magnetic field that E and B produce, sir?
Vector C due to E. Okay. So due to E is like this and point O is this side. So apply the right hand thumb rule. Place the current finger in the direction of current and curl the fingers. So it will be in the upward direction. This will be the direction of magnetic
It's
field.
not exactly upward, right? Because
It is.
E,
This perpendicular distance is going to be the same, no, because they both are in different planes. Understand, O is in the plane of the paper, E is not in the plane of the paper, it is perpendicular. So from a
Sir,
perpendicular,
OA
on the,
isn't perpendicular to OE, sir, in this case.
why? Which one?
OA isn't perpendicular to
Why are you
OE
concerned about OA?
because
I'm not,
magnetic field will be perpendicular to.
that is what I'm saying. See, due to E and B, they get nullified. Due to D and C, they get nullified at point O. A doesn't have any counterpart. Due to A, there is going to be magnetic field existing. That is what I wrote. Mu naught I by 2 pi r.
Okay, sir.
See, if the wire is like this, the point is here. Whether you take the point here, here, anywhere, okay. So what locus does the point form? It forms a circle because it is equidistant. So all the distances are perpendicular distance. Okay, so that's what you need to visualize. Read the question carefully. So each carries a current out of the plane of paper. That is more important. So what will be the field if current in one of the wires, say A, is switched off? Then what would have been the field?
0.
Then it would have been 0 because A is the only one which is generating the field. What if the current in one of the wires, say A, is reversed? What would have happened? Only the direction of magnetic field would have changed, but the magnitude is going to be the same. Is that point clear?
Yes, sir.
That's it. The magnitude F between two straight parallel current carrying conductors kept at a distance d is given as F is equal to mu naught I1 I2 divided by 2 pi d, where I1 and I2 are the currents flowing through both the wires. Use this expression and sign convention and draw the force of attraction is assigned a negative. Use the expression and the sign convention that the force of attraction is assigned a negative sign and force of repulsion is assigned a positive sign. Draw a graph showing the dependence of F on I1 and I2 and D is kept constant. So F is equal to mu naught I1 I2 divided by 2 pi into D. So what are they asking? When F is a function of I1 I2, when D is kept constant. So force is directly proportional to I1 I2. Right. So how will the graph look like? So the graph can either look like this or it can look like this also, depending on whether they are going to be attractive or repulsive. Here, nothing is mentioned in the question, right? So whether you draw this graph or this graph, you should get marks. When the product I1, I2 is maintained constant at a positive value. When an I1, I2 is kept constant at a positive value, then can I say F is inversely proportional to D? So F is inversely proportional to D means what will you get? You should get a graph like this. When the product I1, I2 is maintained at a constant negative value. So F should be inversely proportional to minus D. So the graph will be something like this. The rectangular hyperbola. Are you able to understand this?
Sir, the last graph is in fourth quadrant, sir.
Yes, it is in fourth.
Okay, sir.
See, actually, in the solutions, right, it is exactly given in reverse of what I've drawn. But I was reading the question again and again. There was nothing mentioned whether the currents are flowing in the same direction or opposite direction. Unless that point is known, we cannot conclude which graph is right. So if you have drawn either of them, you will get marks.
Okay, sir.
So coil of number of turns capital N and area A is rotated with an angular speed omega in the uniform magnetic field and connected to a resistor. Reduce the expression for the maximum induced EMF. So what are you supposed to get? NBA omega. So E is equal to what? According to Faraday's law, minus N into d phi divided by dt. So it will be what is happening here. The orientation is changing. So minus N into what is going to be the magnetic field? Magnetic field is B only. What is going to be the area, it is going to be A only. What is going to happen to the orientation? It will be cos omega t divided by dt. So minus NBA into derivative of cos omega t is going to be minus sin omega t into omega. So answer will be NBA omega into sin omega t. And this is going to be the induced EMF, but they ask the maximum induced EMF. So maximum induced EMF will take place when the value of sin omega t is 1. So E max will be equal to NBA omega, and this is the value of E naught, which we use in the alternating current. Right. So what about the power dissipated in the coil? So power dissipated in the coil is E into I, because it's a resistive coil. So what is the value of E? E is this value, N square B square A square omega square sin square omega t divided by R. Why did I write it like that? Because it is also written as E square divided by R. So this is going to be the power which is dissipated instantaneously. So if I calculate the average power, what will I get? It will be N square B square A square omega square divided by R multiplied with the 2. Why did I write a 2 in the denominator? Let me see who is able to answer this. Because
Sir,
the
average of sine square will be
average
half.
value of sin square omega t is half. Okay, so this point, if you don't know, please make a note of it. See, generally, since they ask power dissipation, if you leave it with instantaneous also, you're supposed to get marks. Okay. Because omega is given in the question, so nothing wrong. You can use it. But for maximum induced EMF, you should not have sign. Okay. An electrical device draws 2 kilowatt power from AC source. Voltage is 223 RMS, which is equal to square root of 50,000 volt. The current differs, that is lags in phase by a value of tan phi is equal to minus 3.4 compared to the voltage. Find R. So how do we solve this, guys? So what is given in the question? Power is equal to 2 kilowatt, that is 2000 watt. So current lags. So current lags means what will be the value? Since you are getting a negative value of tan phi here XC is greater than XL. Okay. So why did I take XC and XL? Why didn't I take it as purely resistive? Had I taken it as purely resistive, then there is no question of lagging or reading. Why didn't I take it as purely inductive or capacitive? Because for inductive and capacitive, what is the value of phi? It is pi by 2. But here tan phi is not infinite, it is minus 3/4. So it should be an RLC circuit.
Sir, for capacitor, current will lead, right?
Whatever it is, but here I'm talking about, I'm only concerned about lags in phase. You want that doubt to be cleared? Yes, current leads the voltage by pi by 2. That is there. What I'm saying, did you understand why I didn't consider a pure resistive or capacitive circuit?
Yes, sir.
So what is the value of resistance here? How do we find the resistance? So power is given, right? So when power is given, how will you calculate the resistance? So power is equal to V square divided by Z, because it's a RLC circuit. So what is the value of power? 2000 is equal to V square is 50,000 divided by Z. So what will be the value of Z? Z will be equal to 4. 25. 2000. It should be 25, sorry. So Z will be equal to 25 ohm. Am I right? Guys, tell me one thing. When will an RLC circuit behave like a purely resistive circuit? When will an RLC circuit behave like a pure resistive circuit? When it is under the condition of resonance.
Resonance.
Under the condition of resonance, what is going to be the current flowing through the device? It will be the maximum current. Am I right? Right. So can I write Z is equal to V divided by R when it is in the purely resistive condition, when it is a resonance condition? Okay, I'll come to that point. So we found Z, no. What do we need? We need R. So Z is equal to root of R square plus XL minus XC the whole square. Or in this case, I will take it as XC minus XL because XC is greater than XL. So what is the value of Z? It is going to be 25 is equal to square root of R square plus XC minus XL the whole square. Right. Now tell me, squaring on both the sides, what do we get? 625 is equal to R square plus XC minus XL the whole square. Am I right? But what have they given in the question? Tan phi is equal to minus 3 by 4. So what is tan phi in this case? It is XC minus XL divided by XC minus XL divided by R. So again, squaring on both the sides, what will we get? XC minus XL square is equal to 9 by 16 into R square. Take this and substitute it here. So 625 is equal to R square plus 9 by 16 times R square. That is 25 R square divided by 16. This and this will get cancelled 25 times. So R square is equal to 25 into 16. R will be 5 into 4, which is going to be 20 ohm. So resistance is 20 ohm. Again, taking this and substituting it here, what will you get the value of XC minus XL the whole square as? 625 minus 400 is going to be 225. So XC minus XL will be equal to 15. Clear? Find the value of IM. So IM is maximum current, which is I naught. So you know the value of ERMS. So if ERMS is known, how will you calculate IRMS? IRMS will be equal to VRMS divided by Z. VRMS 223 divided by Z is how much? 25. So 223, actually if I take it as 225, it can be approximated to 9. So I naught will be root 2 times IRMS, which will be root 2 times 9. So this is going to be the value of IM. Okay. So this is all about this question. It is a tough one only, but mark it as important and do it again. So what is the answer for this? Find the value of the phase difference between the current and the voltage in a series LCR circuit, which one leads in phase, current or voltage. So what you do, find the value of the phase difference. Can you find the phase difference? Tan phi will be equal to XL minus XC divided by R. Okay. If this value comes out to be positive, then XL is greater than XC. If it comes out to be negative, then XL is less than XC. That's one. So can you calculate XL? Omega is equal to 1000. Omega is 1000. So XL will be equal to 1000 into L, which is 100 into 10 power minus 3. So what will you get? 1, 2, 3, and this is gone. So you'll get 100. Similarly, XC will be equal to 1 by omega C, 1 by 1000 into 400. 2 zeros, and this is gone. So 1, 2 divided by 5, which is going to be 0.4. So X is going to be 0.4. Oh, sorry. 1 by omega L, no? Sorry, 1 by omega C, no? 1 by 1000 into 400. So it will be 10 power minus 5 divided by 4. And you have,
Sir, why it is 400?
I took resistance by mistake. 2 into 10 power minus 6. So 1, 2, 3, this will be 3. So 1000 divided by 2, 500. Sorry. So there is 100 ohm, this 500 ohm, and the resistance is 400 ohm. Seriya?
Yes, sir.
So since XC is greater than XL, you can say current leads the voltage because capacitor is dominating. Okay. Without making any change, find the value of additional capacitor C dash to be connected in parallel with the capacitor C in order to make the power factor of the circuit unity. So if you take another capacitor and connect it in series in such a way that the power factor should be how much? Unity. So if the power factor is unity, cos phi is equal to 1, then what can you say? R will be equal to Z. So R is equal to, what is the value of Z, guys? Is it not root of R square plus XC minus XL the whole square? Upper squaring on both sides, R square will be R square plus XC minus XL the whole square. R square and R square are lost. So XC will be equal to XL, which implies XL is omega into L will be equal to 1 by omega into C equivalent. So which implies omega square will be equal to 1 by L into or C equivalent or C equivalent will be equal to 1 by omega square L. So C equivalent evlo 2 plus C into 10 power minus 6 is what I'm taking. This should be equal to 1 by omega square is 10 power 6 into L is 100. So this 10 power 6 goes to the other side. Then 2 plus C will be equal to 1 by 100, which implies C is equal to, how much is it? So C should be equal to how much? How am I getting a negative value? L is how much? 100 millihenry. 100 into 10 power minus 3. Then it should be 10. So C should be equal to 10 minus 2. It should be 8 microfarad. I think a 10 and answer. Yeah, 8 microfarad is the answer. Okay. Did you understand? This is NCRT. You can refer the textbook. This is again theory. You can refer NCRT or videos. This is also NCRT, or you can refer the videos. Answer. See, I believe most of you have exam tomorrow. If you can finish it fast, you can go and study. So what is the answer for the 34th one? Mass spectrometer, the ions are sorted out by
Is it C?
C, accelerating them through electric and magnetic field. Radius of the particle in radius of particle in second magnetic field B naught. So what will be the radius, guys? Very simple, ra. MB divided by QB naught. So which of the particle will trace a circular trajectory with largest radius?
Proton.
Proton. Alpha particle 4 times illa adoda mass. Alpha. We did a problem also on alpha particle and beta particle. The mass of the particle in terms of Q, B naught, B, R, and E is going to be how much?
B, sir.
How did you find out?
Same.
So V is equal to
R.
V is equal to E by beta. Okay, R in so R is equal to
R equal to this.
MV divided by QB naught. R in is but. So E is equal to VB upon entering the V இருக்கிற இடத்துல can I write it as E by B?
Yes, sir.
So V, I'll replace it with E by QB into B naught. This is R. So they want M, right? Mass of the particle will be equal to, actually this is by, okay, QB B naught into R divided by E. Correct. That's the answer. The particle comes out of the velocity selector along a straight line because what will happen? The electric and the magnetic force balance each other. That's what we learned in the derivation. See, I'm asking you again, is there anyone who needs help in the derivations in this chapter? I asked you last time also, none of you spoke. Is there anyone who needs help in this? Don't worry about others. If you need, please let me know. At least drop a message in the chat box. If you don't want to speak. If anybody needs help in the derivations of this chapter, please let me know.
Sir.
Tell me that.
Sir, I have a doubt in the question of the mutual inductance, sir, about two coils.
Which one?
There was a question, I think 3 marks, I think, sir.
Yeah, other than finding the mutual inductance of one with respect to another.
Yes, sir.
I already did it. You can have a look at the video later. You didn't join by that time?
Yes.
Okay, just have a look at it, no, once the video is uploaded.
Yes, sir.
So answer for this one. No, I'm asking Kaushik, my question is, it's not about the problems related to this question paper. I know, I'll tell you one thing, guys. There's an honest thing. My papers will be slightly tough only. Here, if you're able to score 50 plus, both you can definitely expect 65 plus. 65 plus is for sure. That is, if you get full marks to your practicals, 95 is what you can score, which is a very, very, very good number in physics. Okay. So any kind of help needed, please, I want you to open up and speak rather than regretting at later point. Because you have time, any help needed, please reach out to me. Don't hesitate. The value of the voltage across the secondary coil is. So primary one is secondary one is the primary coil is connected to main supply of 120 volt and the secondary coil is connected to a resistance of 0.6 volt. The value of voltage across the second coil is. Answer. So ES divided by EP will be equal to NS divided by NP, which implies 2000, 50 divided by 2000 will be equal to NS is how much? Sorry, this is 120. Oh, sorry, ES divided by 120. So this will go 4 times. Answer is 40. Answer will be 3 volt. Next term. The current in the bulb is. So ES into IS is equal to EP into IP. ES is 3. Or I can write IS is equal to ES by R. So what is the value of ES? 3, right? So 3 divided by resistance or 0.6. So 30 divided by 6. 5. Option D. D irka. That's the answer. The value of current in the primary coil. So ES into IS is equal to EP into IP. So 3 into 5 is equal to primary coil. How much is the voltage? 120 into IP. So this goes 24 times. So 1 by 8 varum. So IP will be equal to 1 by 8. 1 by 8 is going to be 0.125. Okay. Power in the primary coil. Multiply both. No, 3 into 5, 15 is the answer. Power in the secondary coil, same 15. Because in an ideal transformer, there is no power loss. So by now, you should have understood one thing, that you should attempt the case study based questions first, then go to the 5-mark questions, and then go to the 3, 2, and at last do the 1-mark questions. Don't start with 1 mark at all. Don't start with MCQs. Okay. And secondly, this year's board pattern does not have the options. It is subjective. For case study base, there are options. There will be no options provided. So they are subjective based, which I'll start from the full portions test part. As of now, I'm giving you these options for safer side. Okay. Is this clear?
Yes, sir.
Okay. So that's all with the paper. So remaining, you have any doubts, reach out to me. Right? Any more doubts, or we can wind up?
No doubt.
Sorry, you have a doubt?
No doubt, sir.
Okay, then we'll wind up.
Thank you.
Thanks, sir.
Hmm.